Okay, so we've been looking at perfect squares, difference of squares. Now we're going to look at the sum of difference of cubes. And the nice thing about cubes is, I'm just going to start right with the examples. And we'll look at 34. So z cubed plus 64. So the first thing we're going to notice is that the exponents are in factors of 3. Right? When they're squares, they're factors of 2. There could be some overlap in here, and I think we'll see an example where there's an overlap and you can take two approaches in future videos. But for right now, we're going to look, hey, this has a cube up front. So we will go to our pattern for the sum of cubes. Well, the question we want to ask is this a cube? Well, if z cubed implies that its root, or its cube root, is z, then we have to actually ask, well, 64, is that something cubed? And so 64, go ahead and run to the calculator, and you plug in the cube root, and we'll find that the cube root of 64 is 4. Because 4 times 4 is 16, 16 times 4 is 64. And that's how our cubes work. Triple multiplications, right? Boom, boom, boom. So our pattern says that if we have a cubed plus b cubed, it came from a plus b times a squared minus ab plus b squared. Now, thing to note here, is whatever your sign is, that's what the binomial sign is. And the trinomial middle term is the opposite of that. And if you want to memorize the pattern, it's one of those things, the more you work with it, you'll see it come through. And that happens because we need that negative sign to kill middle terms, to cancel them out, so that we just have two terms in our final thing. So our a was z, and our b was 4. So we take this and we can say z cubed plus 64 equals z plus 4 times z squared minus 4z plus 16. Whew. All right, and so that's how our cube formula works. We're looking for cubes in there. And the same thing happens if there's a negative or a positive. Now, let's look at one here that shows a nice little trick we want to keep in mind. So 64x minus x to the 4th. Well, I don't have any cubes, right? X to the 4th isn't a power of 3, and x to the 1st isn't a power of 3. 64 is a cube. We just did it in the previous one. But those two variables aren't. But both of these terms have an x. We have a GCF. So let's factor out our GCF. Let's pull out the x that both have and see what's left behind. That leaves us with a 64 minus x cubed. Hey, look. Now we have a difference of cubes. All right? And this is something we're going to have to remember as we do more and more, is the first thing we always want to do is get rid of a GCF. That'll give us a factor out front, and then we can focus on what's left behind. So using my pattern, my a is 4, because the cube root of 64 is 4, and my b is x, because the cube root of x cubed is x. It's negative, so I'm going to have 4 minus x times 4 squared, which is 16, plus, because the sign changes, 4x plus x squared. Now you might see this written a couple different ways. We can take the negative of this, negative x minus 4, and write this if the variables are in descending order, the standard form. And so that negative we can pull out front. And we get this. And that'll tend to be the solution, you'll see. All of these mathematically are equivalent, but what we're doing is we're kind of ordering it in a standard form so that when we see things, we get used to how the quantity moves about with it. If you write things in the same order each time, as you see different things, you can notice their differences or their patterns. And so the tendency is to write our variables alphabetically and in descending order of power, and to factor out the negative signs all the way into the front. And so this is how our cube formulas work.